Good morning everyone. Today we are discussing about another topic of the subject robotics in medicine, that is differential motions and change. First we look for, after completion of this topic, you must understand about what is differential motions and what are all changes. So differential motion means what? That is a very small change in motion. So differential change between frames means what? How small change of a robot and core coordinate frame are described, and how small change look when some see from different reference frame. So basically what is a frame is, it is just a coordinate system attached to something. Two types of frame we have, fixed frame and current frame. What is a fixed frame? Fixed frame means what? It is a reference frame that do not move. Current frame attached a moving body. So the differential operator, we can represent it by using the symbol del, a differential operator relative to fixed reference frame. So we have to describe the change in two ways, that is change measured from fixed frame written as del, that is how much did the frame change as seen from a fixed frame, and that is next is change measured from current, that is T del, how much did the frame change as from itself. Motion is change, point view is different, that is T is what? Transformation matrix, it tells the position and orientation of the current frame. So we have the small change in the transformation dt equal to del matrix del into matrix T, that is T into del transports, multiplying the both side by T inverse, that is T inverse into del into T equal to T inverse into T into T del, that is del T equal to del into T inverse into T. So this equation can be used to calculate the differential operator relative to the frame delta del transpose. Assume that the frame T is represented by NOAP matrix. So we get some equations. So we get the T inverse equal to, the inverse is that back to the original frame, and we have nx, ny, z, ox, oy, z, ax, ay, z up to, then is minus pn, p0, po, pa and pa, that is the position, and another elements are the rotation matrix, tell how axes are oriented. Next we have the equation for del equal to, we have another matrix, that is dou x is the small rotational vector and dx equal to what? Small translational vectors. So finally we have del transpose equal to, multiplying both the matrix, that is T inverse and del, we get another large matrix. So del transpose is made to look exactly like del matrix, but all elements are relative to what? The current frame, where these elements are obtained from the previous multiplication of matrices and summarized as the follows, that is del x transpose is equal to dou x transpose equal to dou into n, dou y transpose is equal to dou into o, the dou z transpose equal to dou into, that is the component of force acting along xyz axis. This dx transpose is n into that matrix, that is turning effect due to frame. So torque is that is turning effect means what? Torque, that is turning effect is the torque of that frame, and that way we have to summarize the matrix. So that's all about the differential motions and the change. Hope all of you understood about the equation and derivations on the derivation of that matrix. That's all. Thank you.